Okay, we are recording, okay? This is lesson 3. Okay, so I have a question. What did your group come up with? Do you connect the dots? Do you not connect the dots? You connect the dots is correct. Okay, everybody listen. Jesse, is that right?
Yeah.
Jesse, tell me why you connect the dots.
Because you can have a negative cost, and that's what would make it not connected.
So cost or tax would be y. A negative y would mean down below the axis. But that doesn't really have anything to do with connecting. Good connection, and we will talk about negative things not making sense a lot. So good try. Yes, sir?
Because it's continuous.
Why? Continuous is the correct word. I love that.
Because the tax always expands with every...
The tax changes, but I could just add more dots. Go ahead.
So it's a constant or continuous because no matter what sales price you have, it can be any price when you still have the tax, right? So anywhere on the number line, it would be the same.
And if I just do the dots,
Right, then it wouldn't show you that.
then it's just those numbers. If I just do the dots, like on the one that this group did, that means you can only spend 10, and you can only spend 20, and you can only spend 30. But can you guys go to the store and spend $5.53? Talk to me. Yeah. So it's, guys, so it's everything in between, so you connect the line. Good. Okay, here we go with lesson 3. Okay, lesson 3 will be on your quiz. I do have to go a little faster than normal. I did not finish the lesson to my 1010 students yesterday, and that is not a good thing to happen right before you take a quiz. So I do have to go a little faster than normal. Okay, you guys tell me we're reviewing for the quiz. Okay, the x value. Let's just shout out some things. X value. Is that the input or is it the output? Input, right? That's something you need to know for the quiz. Is it independent or is it dependent? It's independent. So the input is the x, which means you label it on the x-axis. So the input always goes on the x-axis, okay? The y value, just don't read those words and just kind of try to remember. Is the y value the input or the output? Everybody tell me. It's the output. Is it independent or is it dependent? Which one is it? Talk to me. It's dependent. Yes. And the output always goes on the y value because on the y-axis because it's the y value. Okay. You guys, you're going to graph some points today. I need you to remember how to do that. So this number right here tells you to go right or left. And the one underneath it tells you to go up or down, okay? So, for example, if you had negative 3, 4, everybody write that down. You start at the origin, you go left 3, because the first one's a negative. Then you go up 4, and you make a dot. Okay, let's do one more. 0, negative 6. You start at the origin. How far do you go right or left? Everybody talk to me. You don't, and then the 6 is a negative, so you would go down 6, make a dot, and you're done. Okay? So discrete. You guys, discrete means do not connect the dots. It's isolated points. The example that we just did in our activity was not discrete because we connected the dots. Discrete means it doesn't make sense to connect the dots. Okay, so everybody look right here. The high temperature in Kaysville, Utah during the summer months is displayed on this table. Represent the information graphically. Be sure to label the axes. Everybody in the room tell me, when you take the quiz, you have to label the axes. So what am I going to put on this horizontal axis right there? Tell me. Month. So write that in. And on the left side, I'm going to put, talk to me, temperature. Okay, so then right here on this mark, I'm going to make a mark and I'm going to put June. Then I'm going to make a mark and I'm going to put July. And then I'm going to make a mark and I'm going to put August. Now look how big those numbers are. They're like 87 and bigger. So I could go like by 10s and go up to, or I could go by like 25s and go up to 100. But then the difference between 92 and 94 is going to be so small I won't be able to tell. So I'm going to do this funny thing that's like this, and you just do this little line like that, and that tells you I'm not starting down at a 0. So I'm going to go here like 80, and then I'm going to go 85, and then I'm going to go 90, and then I'm going to go 95. You guys, this is really important, so look. The distance, don't write this on your paper, but the distance between 80 and 85 is 5. Between 85 and 90 is 5. Between 90 and 95 is 5. That's super important that those are consistent. You can't do like 5 and then 10 and then 12 or whatever. They need to be consistent. This right here is not 5. That's 80, right? Between 0 and 80. But this little wiggly thing made it okay to do that abnormal, numbering like that, okay? So that's how you do that. So go to June, go to 87, and everybody make a dot. Go to July, go to 94, and make a dot. Go to August, and go to 92, and make a dot. And do you see how you can tell a difference now between the 94 and the 92? Okay, now everybody listen. So when they did this, they just took the temperature reading one time. And that was on June 1st, July 1st, August 1st. 3 readings. Should I connect my points? No, because I didn't take a reading on the 2nd, or the 3rd, or the 4th, or the 5th, or the blah, blah, blah. It was just the 1st, and then the 1st, and then the 1st. So you do not connect the dots. This is an example of a discrete graph. Who says I understand? Raise your hand, let me see. Is this an example of a discrete graph? Yes. The explanation is the temperature reading was only noted on the 1st of each month.
So discrete means not connected.
Correct, correct. Good, honey, good clarification. I only took it 3 times, okay? Okay, continuous. A graph is continuous if the points can be connected. What we just did on our little activity was continuous because you can have any kind of a cost, right? Here we go with question 2. You have a job. You make $9 an hour. When you get to work, you clock in, and when you leave, you clock out. Complete a table, okay? 1 hour, how much do you make? Everybody talk to me. $9. 2 is, tell me, 18, 3 is 27, 4 is 36. Now let's graph it. Everybody in the room tell me what goes on the x-axis. Hours. So let's label that. It's kind of squishy and I'm sorry about that. Over on the side is pay. Hours are going to be 1. You have to label these numbers. 2, 3, and 4. On the pay, you don't have to go by like 10s or 5s or 15s. You can go by 9s. There's nothing wrong with that. So I'm going to go 9, 18, 27, and 36. So 1 is 9, 2 is 18, 3 is 27, 4 is 36. Discrete or continuous? You tell me. Why? Why continuous? Go ahead.
Because you can work for an hour and a half.
You're exactly right. Perfect, honey. So if we leave it like this, then your employer's saying you have to work exactly 1 hour, exactly 2, exactly 3. Well, that's silly. That rarely happens, right? So you are exactly right, honey. You connect those dots, you draw an arrow at the end, and that is called continuous. It goes on forever, continuously, okay? Write an equation in function notation to represent the situation. You have to read in this class. Guys, look. Function notation. Someone tell me what function notation is. F of x. Good. Now I want you to write down the equation. This is symbolically. We did this on our activity. Sorry, I'm having issues. Okay, symbolically. So the symbolically is going to be f of x equals, tell me what to write. 9. And then would I put like m? No, because remember we talked about if it's f of x, then the variable is going to be at, talk to me. It's going to be an x. Good. So come right here, erase it, put in an x, and you're done. Okay? You have, say it again?
Do you have to put parentheses around the line?
You don't, because if you have 9x, that means 9 multiplied by x. If you have 9x, it still means 9 multiplied by x. If you put it, it's okay. You don't have to. Okay? Okay, question D. Write a sentence and explain what is happening. Okay? Please don't say you make $9 an hour. That's evident. How do you figure out the pay according to hours? Okay, I'm going to give you 1 minute to do it, and then I'm going to call on somebody. Okay? Okay, Jackson, read your sentence, bud.
Multiply hours worked by 9.
That's good. Now, I don't know if that's a full, it's not a full sentence. Multiply the hours worked by 9. I don't think that's a complete sentence. Okay, so maybe add to yours to determine the pay, you multiply the hours worked. So why don't you change that, okay? But you're exactly right. Make sure it's a complete sentence. Yes, sir. Good? Anybody else? That's really what it needs to be. That's the gist of it, okay? Okay, here we go. Now we're going to talk about functions again. You guys, when we had ordered pairs, remember you determine if it's a function if the x's don't repeat, but now we have graphs. So you do the vertical line test to see if it's a function. Everybody grab your pencil, and on 3A, I want you to draw a line right there, okay? Everybody in the room, tell me if you know, is that a function?
No.
The answer is no. Why is the answer no? Because it hits it twice. You're done. Literally, that's all you have to do on the homework and quiz and everything like that. But I want to give you an explanation, so we're going to write more. See that dot right there? It hits both the vertical line and the V, sideways V, and that ordered pair is don't go right or left, that's a 0, and then up 2. This right here is don't go right or left, that's a 0, and then go down 2. So both of those points are on the V, and if you notice, the x values on those points are the same. That means it's not a function. So guys, if you ever draw a vertical line and hit 2 points, the x's are the same, so it's not a function. Okay, who says I understand that? Raise your hand, let me see. Great. Okay, look at question B. I want you to draw your vertical line this time, you guys, like over here. So that cubic is what that's called. It starts going like really steep on the right and the left, but does it ever go completely vertical? Talk to me about that. No. So would that red line ever hit it more than once? No. So is it a function? Yes, it is. Very simple. There's literally no work. You just answer the question. Yes, honey?
So on the quiz, if it's not a function, do you want us to tell you like why, like name the coordinates?
You know, the only reason you would have to is if you're asked, and I've never seen that happen. I write my tests and I present them in the same way that Weber's going to ask you on midterm and final, and I've never seen it, but that's a good question, honey. Everybody look at part C, question C, and tell me, is that a yes or is it a no? It's a no, because if you draw your vertical line anywhere between 3 and -3, it hits it twice, okay? Okay, increasing. Everybody watch right here. Watch my pen. I'm going to try something here. Watch my pen. I start on the left. Oh, that's not what I wanted to do. Let me try again. I start on the left. Oh, that's not what I want to do. Never mind on the little trick. I'll do it later. I'll start on the left. I travel to the right. And as I travel to the right, my pen goes up, that's increasing, like that graph right there. It doesn't matter if it's like super steep or kind of flat, as long as it's increasing, that's a positive slope and the graph is increasing. Decreasing is easy. Look right here, you start on the left, and as you travel to the right, your graph goes down. That's decreasing. Here's constant. It's easy to understand. It's a horizontal line. You know something that's constant, you guys? Look, my pay. So in the summer, I don't work at all. So if this right here, you guys, is hours worked, and this right here is my pay is consistent no matter how many hours I work. In the summer, I don't work. I still make the same amount of money. This week, I probably worked 45 hours this week. I'm like working like a crazy person. So my pay is still the same. In the summer, if I work nothing, in the school year, if I work 45 or 35, whatever it is, my pay is always the same. That's constant, okay? Okay, increasing, decreasing, constant. This is important. Here are the 3 things that you need to remember about increasing, decreasing, constant, okay? These are X values only. They are never Y values. Okay? The other thing you need to remember is that you go from left to right as you do this. And the third thing you have to remember is that you always use parentheses and you never use brackets. Okay? Make sure you remember that. When you go through your notes to review for the quiz, you're going to read this and you're going to remember, and it's going to help you to do well on the quiz. Okay, yes, honey?
What does it mean, X values only?
We're going to talk about it right now, okay? So if you don't understand by the time I'm done, then ask me again, okay? Okay, everybody, look at your graph. I want you to think of it as a road map, okay? So look, you don't have to highlight, but look, you're driving down this road, and then you change to this road, and then you change to this road. So every time you change roads, I want you to put in that ordered pair. So this guy right here is left 3, that's -3, up 4, that's +4. This guy right here didn't go up or right or left, so that's 0, and then we went up 1. I changed here, so that is right 3 and up 1, and then I ended right here at 6,6. Now I want you to take your pencil and very lightly, I want you to cross through all of the second numbers in those ordered pairs. I need someone to raise your hand and tell me why we just did that. Because it's just X values, right? It's never Y. So I crossed them out so that I don't get confused. Okay, now I want everybody to look at the yellow. I'm going to start on the left, and I'm going to travel to the right. Watch my pen. As I travel from the left to the right, you tell me, watch my pen. Am I increasing, am I decreasing, or am I constant? Tell me. Decreasing. Where does the decreasing begin? Tell me. -3. Everybody write -3. How do I close my -3? Read number 3. Always parenthesis. Where did my decreasing end? How do I say that right there? 0. Close it off. Now you guys watch this. I'm changing roads. You tell me increasing, decreasing, or constant right here. Constant. Where does the constant begin? 0. Where does the constant end? 3. Always parentheses. What's happening here? Watch. Here to here. Talk to me. What's happening? Increasing. Where does the increasing begin? 3. Where does the increasing end? 6. Easy. Who says I get it? Let me see a pie. Yay. Yes, honey.
So, if there's an arrow at the end and it continues, does that just written as infinity?
It would be infinity. It would be infinity. Good, honey. We're going to talk about that. Okay, here we go. Find the local maximum point and the local maximum value. So when you read point, you're going to write it as a point, which is x, y. When you read value, you're going to write it as a value, and it's going to be y equals some number. So make sure you write both of those down and you understand. So let's do this example. Find the local maximum point. Guys, you have a local maximum here, and you also have a local maximum there. So you list them as a point because it says local maximum point. So the first one is go left 1, don't go up or down, that's -1, 0. The next one is go right 1, and then don't go up or down, so that would be a 0. That's your answer. Local maximum value, that's going to be, oh, 2. Thank you very much. See, I told you I'd make mistakes. Thank you for correcting me. The local maximum value would be y equals, and then it's what those are equal to, which is what, everybody? 0. Okay, now I'm going to throw a little twist in here. Everybody listen to this. What if this guy went up to here? Okay, don't change yours, just watch. What if it went up like that? Okay, then I would have 2 local maximums. They would be -1, 0 and 2, 3. That would be local maximum points. I would have 2 local maximum values, which are y equals 0 and y equals 3. So a local maximum is just a maximum within a particular region, okay? It doesn't have to be the highest, it's just the highest in a region, okay?
If we were writing that on a quiz, could we just use a comma instead of writing y equals twice, or would we write it twice?
You write it twice. Write it twice, okay, honey? And yes, and I'm so glad that you're like caring about that, because in this class, notation is so important. If you don't write it right, if you don't write it correctly, they're not going to give you credit. So that's good, honey. Okay, a local minimum point and a local minimum value. You guys, here's what we're talking about right there. Now, I don't love this graph because they didn't actually tell me that point, and you can't guess. So I'm just going to tell you that it's 0.5, -5. That's the value of that point. Okay, so the point would be 0.5, -5, and the value would be y equals, talk to me everybody, -5. Yeah, y equals -5, whatever the y value is. Okay, let's go ahead and do question 5. Okay, I'm going to try to keep a nice pace on this so we can try to finish 6, okay? At what point does the function have a local maximum? Look right here. Point. Maximum. So I'm talking right there. You write it as a point. You don't go right or left, so that's a 0. You go up 4, 0, 4, and you're good. What is the local maximum value? If it says value, you write y equals. Everybody tell me, y equals what? 4 is correct. Good. At what point does it have a minimum? You guys, we're talking about this. So that would be, you tell me, what is it?
0, 2.
Is it 0, 2? The first one tells you to go right or left, so where do I go? 2, and then up or down is 0. Good. Local, this instead of maximum, that should say minimum. Local minimum value is going to be y equals, everybody in the room tell me. Y equals 0. Yeah. List where it's increasing, list where it's decreasing. Everybody watch. Start on the left, travel to the right. You tell me what's happening right here. Increasing. Where does the increasing begin? Forever that way, right? Negative infinity. Everybody watch this. The increasing ends at a 4. That's wrong. It is not 4. I need somebody tell me why it's not 4. Hope, why is it not 4?
Could it be because that's not like the highest point? It keeps on going.
Nope, because I've got to call this something. Good try, honey. I've got to call that something. I don't call that 4. Why is it not 4, honey?
Because it's the x value. Not
Yeah, remember, never y. And the 4 is the y. So that is not the right way to write that. It is a what? Everybody tell me.
0.
It's a 0. This is all going to be on your quiz, so make sure you're engaged. Everybody look here. What am I doing now? Increasing or decreasing? What's happening? Decreasing on the yellow. Everybody in the room, tell me, where does the decreasing begin? 0. Where does the decreasing end? 2. Now what's happening? Look at the green. What's happening, everybody? Increasing. Where does the increasing begin? 2. Where does it end? Forever. Who says I get it? It's going to be there. Okay, good. Okay, question 6. You're running a marathon. The following graph displays the speed that you're running throughout the race. Everybody look at question 6. Now this seems a little impractical. This is actually a half marathon. This to me right here seems a little impractical. Can someone explain what I'm talking about? That point. Go ahead.
The speed spikes up so freaking flat?
No, but good try, because sometimes you speed up and you slow down. What is it?
No one starts at, is that 6? No one starts at 6 miles.
You're starting your half marathon at 6 miles an hour. Okay, now I'm going to tell you right now, I did that. I've ran the Ogden Half Marathon like 4 times. And when you run, there are thousands of people. So you're in this big mob and you start running, but I haven't crossed the start line yet. So I run a half a mile before I even start my 13.1. So I really am starting, you know what I mean? So it's a little weird, but it's possible. Okay, so here we go. Identify the independent. Everybody in the room, tell me quickly. Miles traveled, right? It's on the x-axis. Everybody tell me the dependent. Talk to me. Speed, which is written in miles per hour. Very good. Interpret the graph. Okay, so let's do it. Okay, when I start running, comma, well, that's not a good way to say it. When I cross the starting line, yep. When I cross the start line, comma, I am already running. Finish. 6 miles per hour. Thank you. Okay. For the next 2 miles, finish. I continue running. Keep going. Talk to me. At 6 miles per hour. Okay. Now at mile 2, something happens. So I'm going to say at mile 2, comma, I gradually increase my speed until mile 5. When I hit mile 5, comma, I am running, tell me, about 7.5 miles per hour. What happens now? You start slowing down. You hit a peak, okay? I then slow down at a continuous pace. That's because the line is straight. At a continuous pace until mile 9. I am running, what is that number? 3.5. I am running 3.5 miles per hour at mile 9. Who says I'm with you? I know we're going fast. Who's with me? Okay, then we say, I then increase my speed at a steady rate. That means it's a straight line. at a consistent or steady rate until mile 13.1, till I finish my 13.1. No, that's not true. Until mile 11. At mile 11, this is super long, I'm sorry. At mile 11, I am running, make sure you get all this down, it's going to be on your quiz. I am running 7.5, yeah. 7.5 miles per hour. I continue at this pace until I cross the finish line.
Did you also say until I finish?
Sure.
Okay.
Yep. Okay. One more. I know this is fast. Here we go. You're driving home from work. Okay. So what it says, or what it should say in there, is miles is a function, miles traveled is a function of speed. So everybody put down here miles. Everybody here put speed in miles per hour. Okay. Altogether, you're going to go 5 miles, it looks like, when you come to mile marker 5. So we're going to go, let's skip a couple. So let's go skip it, 2, 3, 4, and 5. And then if you look at the speeds, they're going like up to 72. So maybe we could go to 80. So 20, 40, 60, 80. Yeah, let's go up by 10s. So that'd be 20, 40, 60, 80. Okay, now let's read the words. You're driving home from work. When you come up to mile marker 0 on the freeway, you're traveling at a constant speed of 65. So I'm going to start at 65. You continue there until mile marker 2. So you've got your cruise control on. And you've passed a mile marker, so you can start at that pace, okay? At mile marker 2, there's an accident, and traffic slows down at a constant rate until mile marker 4, where you're traveling about 15 miles an hour. So here is about 15, and you're going to decrease at a constant rate, like that, okay? Between mile marker 4 and mile marker 5, you bring your speed up at a constant rate. When you come to mile marker 5, you are traveling 72 miles per hour. So maybe about like that, and you're increasing at a constant rate, okay? So that you make it to your appointment on time. Create a graph for the situation, express your distance as a word. So I didn't really tell you how far away it was. So, you know, it's not the greatest wording. Let's say it's 6 miles away. Okay, so I'm just adding a little bit to the problem. Then you're going to have to slow down at some point, right? So say you went constant. This would have to be something you were told, and then you would stop at the 6 miles because then you'd be at your appointment. Okay, something like that. Okay, so that is it. Are you guys okay? I know that last little piece was